Hello everyone, welcome back to another session by K21 Academy. Today our expert trainer will be talking about Azure Firewall and hub and spoke architecture. So let's get into the video.
Firewall is our next topic. So let's see guys, what exactly the firewall is, right? So firewall helps you again creating your inbound and outbound rule. Firewall also control your inbound. What is ingress and egress? It is inbound and outbound. You are controlling inbound and outbound through the NSG as well. The difference is, does the traffic of the firewall for the inbound and outbound comes on layer 7. Firewall can understand, your NSG cannot. Firewall can also understand your network layer rule, what you can have, network rule that you can create, right? Layer 7 rule, we call it application rule. In firewall, you can create one. Not only that, you can also create DNS level rule. We call it network rule over here. That which traffic should be resolving on which particular IP over here. Or you can also call it DNS level rule. And it can support netting, network address translation. Now, if you see, these functionalities are not supported by your NSG. Clear? And your firewall also support your packet inspection, because if the traffic is coming over HTTP and HTTPS, right, it comes with the data. Now there is a difference between HTTP and HTTP port and the HTTP and HTTPS protocol, right? So layer 4 traffic deals with the TCP protocol, ICMP protocol, right? There is no HTTP and HTTPS protocol. It was ports which were available. When you are coming layer 7, right, it required packet inspection mechanism that is only supported by firewall, not at NSG level. If the rule says allow, it will allow the traffic. But if your firewall rule says allow and packet have certain, corruption or any kind of a thing which can create problem in the production, firewall can inspect the packet and block it. That too, we have created the allow rule. So firewall is artificially intelligent. AI has been implemented over here. Clear guys? And that is the reason guys, your firewall is a costly appliance and your NSG is free of cost because of this functionality difference. Clear? Yeah, IP masking is a part of your net only, right? That whenever you will be masking your IP, what you did, you will be hiding it behind the DNS basically. Yeah. Or net gateway can be also used for that. Now guys, let's talk about a common scenario. A very common scenario through the firewall that in your production, you cannot open all the websites. Now, why we cannot open all the website? Because my firewall is blocking. Now, how that mechanism work, right? So that is a category of your outbound rule, because where the traffic is generating, if I'm trying to open any website, the traffic is getting generated inside the network and going where? To the internet. So let's say this is internet and the traffic is getting generated. So let's say this is your network. Okay. Now let's assume that this network have a range, let's say 10.0.0.0/16. Now in this particular network, what we have, let's say this is the subnet I have, where I have deployed my firewall. Guys, always remember that whenever we will be deploying a firewall in a subnet, the name of the subnet have to be Azure Firewall subnet. I cannot give any other name. This is how Microsoft identifies that this subnet is reserved for the firewall creation. If you will give any other name, you try to create a firewall, it will throw you an error, unable to find any subnet with the name Azure Firewall subnet. So it has to have a name Azure Firewall subnet. The minimum range that subnet should have is /26, just like your Azure Bastion. So last week when we talked about Azure Bastion, we talked about the subnet name of the Azure Bastion should be Azure Bastion subnet. In the similar way, if you will be creating a firewall, the subnet name has to be Azure Firewall subnet with minimum has to be /26 IPs. Now, how many IPs we are talking about that we minimum required? Remember guys, we talked about a formula. So 2 raised to the power 32 minus the number after the slash. What we have after the slash? 26. So if you minus 32 minus 26 gives you 6. So if you multiply 2 6 times, it will give you 64 IPs. And we know 5 IPs are reserved. So it will give you 59 usable IPs. That is what required. 64 IPs, but 5 IPs are reserved. We talked about reserved IPs for gateway IP, for DNS IP, right? Your network ID and your DNS provider's IP. And the last one will be your broadcast IP. Yeah. So first 4 IPs are reserved. And that is the reason, guys, if you create any machine in your subnet, by default, it gets assigned with .4 IP, because 0 to 3 IPs, those 4 IPs are already reserved. And the last IP of that particular for 0 to 255, last IP reserved for the broadcast. Okay. Coming back, guys. So minimum IPs that you should be giving /26. Maximum, that is up to you. You can give /24, you can have 256, right? So over here, let's assume that the subnet that I have over here is 10.0.1.0/24. Let's say I have given 256 IPs over here, more than enough. Now this is your work subnet, guys. This is your production subnet. All your production resources are available over here. Let's say this is your work subnet, and the range that I'll be using 10.0.0. Or let's say 2.0/24. Okay, and you have hundreds of machine over here. Now just for a demonstration, let's say I have one machine. So what I want, that whenever anyone from this subnet tries to reach to the internet, the traffic should hit the firewall and then goes to internet. So in order to control the traffic, what you will be creating, you will be creating routing table. You required a route table to ensure that traffic directly should not go to the internet. It should go through the firewall. So what you will do, you will associate the entire subnet with this routing table, and you will ensure the traffic should hit the firewall, and only then it will go to the internet. Clear, guys? So you need to create a route table, and you need to update the entry that you will be associating this route table to this subnet, and then you will pointing the traffic to the private IP of the firewall. Now, how you denote any CIDR for this internet? Let's say 0.0.0.0/0. Firewall might have the private IP, let's say 10.0.1.4. So your traffic should hit the firewall before going to the internet. Now, how you can access this machine, guys? If you will be associating the entire subnet to the firewall, what is the by default rule of a firewall, guys? Deny all. By default rule of a firewall will be deny all until and unless you will allow any particular traffic. So the moment traffic goes over here, you will create the allow rule so that the traffic will go to internet over here. So you will be creating what rule? You will be creating an application rule for that. And in order to access this machine to check whether firewall rules are working fine, I will create one machine in the additional subnet. Now this subnet can be the Azure Bastion if you want security. Currently we are in the testing environment, and we know that Azure Bastion at least take 10 minutes for the creation. So I will create one RDP machine over here with a public IP, so that I can access this machine from my machine, and I can access this machine to check whether the firewall rules are working fine or not. This is for testing purpose. We are not controlling any environment over here. Now guys, over here, let me ask this thing. If I will be managing 100 networks, do I need to manage 100 firewalls? One network, I'm managing the traffic through the firewall. So if my production have 100 networks, I need to manage the traffic. Do I end up creating 100 firewalls? It will be very expensive, right? So we need to manage this firewall, and we have to increase the reusability of the firewall. So what we will be managing through, guys, we must have heard about hub and spoke architecture. Hub and spoke model that we will be using. So now we will be touching upon hub and spoke model, and we will increase the reusability of the firewall. Now let's say how. So here, whenever you will be creating any firewall, let's say if that is a network that you have. So first thing first, guys, this network is dedicated for the firewall only. I will not create anything on this. This will be your hub. So hub and spoke is a terminology just like your wheel, guys. You must have seen your cycle wheel, bicycle wheels, your bike wheels, car wheels, right? You have a center that we call it hub, and your spokes are connected to that. So your firewall will be in the center. Your firewall will be your hub, and rest of the networks are in spoke. Now what is that? So let's say this is your hub. So let's assume, guys, this is a network that you have 10.0.0.0/16. Now the subnet that we create for the firewall will be your Azure Firewall subnet. And what you put over here, guys, let's say 10.0.0.0/24. And what you will be providing over here, that is your Azure. Let's say you can say this is your hub VNet. Yeah. And we deployed a dedicated firewall over here. Now let's say I have other networks. Let's say this is my spoke one network, or probably I have another region, I have another network available over here altogether. So let's say this particular network is in the same region where the firewall is available. Let's say this is available in the East US, and you have, and your firewall is also in the East US, and let's say this is your spoke one VNet, and you're giving a range, let's say 192.0.0.0/16. This is another network that you have. This network is available in Southeast Asia, let's say in your Singapore region. And let's say this is your spoke 2 VNet that you have. And let's assume this is the range 172.0.0.0/16. Now, there are two different networks where my production workloads are running. So let's say there is a subnet here, and both are my production subnet. The name you can give, let's say spoke 1 work subnet. The range 192.0.1.0/24, and this is your spoke to work subnet that you have, let's say 172.0.1.0/24. Now guys, we have multiple networks. That too, one network belongs to the different region altogether. Now I have hundreds of resources available in this subnet, and I want that entire traffic of this subnet should hit the firewall before going to internet. This is your internet, and how you denote internet? 0.0.0/0, right? And I want the entire traffic for this subnet should hit the firewall and then go to the internet. So until and unless there is no connectivity, you cannot route the traffic. So connectivity is important. So if this network is in Azure, you can use VNet pairing. If the network is outside Azure, let's say on the on-premises or cross-cloud platform, you can use VPN gateway or express route to create the connectivity. Our last session was for connectivity. So guys, I hope everybody knows how to create a connectivity now. So currently I will create networks and I will create this connectivity using peering. So once the connectivity will be there, what we can do? We can route the traffic, right? And in order to route the traffic, what I will do? I will create a route table and will ensure that entire traffic from this subnet with the help of the route table should hit the firewall and then go out to the internet. Same goes with the another region as well, that I will create a route table. Now, why we required another route table over here? Because it is in the another region. If this network should have been in the same region, you don't require another route table. You can just update the entry over here. So this is the pairing that you will be using over here, and you will be associating and you will be hitting on that particular firewall and then hitting to the outer world over here. Clear guys? Route table is necessary. Without route table, how you know the traffic is pointing to the firewall? Connectivity doesn't mean the traffic should hit the firewall, right? Understand this. Now, if you see this architecture, guys, it is similar to the first architecture what we have seen. There is no difference. The only difference is that the below resources are the part of the different network, isn't it? And that is the reason you are creating the connectivity. If you see, you are using route table here as well, you are using route table here. You have your work subnet over here, you have a spoke one work subnet, a spoke two work subnet, just like that. You have a RDP subnet over here, you have a spoke one and spoke two RDP subnet. If you see this architecture and this architecture is not different. The only difference is between hub and spoke that these two components are available in the another region altogether. And that is the reason you have to create connectivity. If you see, rest of the things are same, isn't it? You are ensuring that entire traffic comes from this subnet, hit the firewall. Here as well, you are ensuring that. Yeah. So this is the same architecture, what we are doing. The only thing is the below two component belongs to the another region, and this is what we are increasing the reusability. You can have another network having a spoke, multiple spoke, add on multiple networks, no problem. The way you are keep on adding these networks, right? So we'll go ahead and see the deployment of the second one. The first one will be by default clear because it is nothing but a same deployment. The only thing is the route table have the entry of the another network. There the entry will be on the same network, nothing else. So we'll go ahead and see the deployment of this architecture now. Yeah. Now guys, this deployment will take approximately 30 to 35 minutes to create everything, right? So there is no limit over here. Whatever number of the spoke that you would like to create, guys, you can do that. There is no limit. The only thing is create only that much of dependency that this firewall can sustain, right? So because you can create 100 connections, 1000 connections, right? But let's say how much dependency you can want to create on the single firewall. That's the thing. Yeah. All right, so what we're going to do now, we will be creating this particular architecture over here. So as we can see that we require three networks, two are in the same region that is called East US. Another one I will be creating in Southeast Asia. And guys, I will just going to use the same naming convention, what you can see in this particular diagram, just to be on the safer side so that we can understand every component over here. Okay guys, going into the virtual network at the moment and creating three networks. So going into this virtual network, going to create a virtual network for hub. So I'm going to put a name, let's say hub RG. Going to give a name, let's say hub VNet. Going to select, let's say East US. I'm going to give the range that I have mentioned over there. So I'm going to give a range, let's say 10.0.0.0/16. And subnet I'll be creating with the name Azure Firewall subnet. And let's say I'm giving 10.0.1.0/24, right? /26 is minimum. I have ample amount of the IPs in this subnet. Yeah. So here we have given 10.0.4, right? Just give me 1 minute. let me follow the same convention. Just give me 1 minute. What we have given in the picture itself. Yeah. So I'm going to open another portal so that I can create multiple resources simultaneously. Yeah. So my network is in under deployment over here. I'm going to create another network, and this network is your spoke one network. And here we require two subnet, a spoke one work subnet and a spoke one RDP subnet. So going into this virtual network, let's say spoke one RG. I'm keeping under separate resource group so that it will not goof up with any of the existing resources. I will give a name spoke one VNet. Region, I'll be selecting East US. Range, as mentioned in the picture, 192.0.0.0/16. The subnet that I'll be giving, let's say, the spoke one work subnet, where my production subnet resources I'll be creating. So I'll just give a name spoke one work subnet, 192.0.1.0/24, and one subnet I'll be creating for my RDP machine that I will deploy in some time. So here I'll just give a name spoke one RDP subnet. 192.0.0.0/24. Yeah, just like mentioned in this particular picture. Similarly, going into this particular virtual network, and this virtual network I'll be creating in Southeast Asia. So what I will be putting over here, spoke to RG. This is your spoke to VNet. And guys, this I will be keeping in Southeast Asia. So I'll just put it Southeast Asia. And this I'll be going with range 172.0.0.0/16 and spoke to. This is your spoke to network that we are creating, right? That is 172.0.1.0/24. Spoke to RDP subnet 172.0.0.0/24. Clear? So this we have given. Just like what we have, just check the naming convention. This is your spoke to VNet. Yeah? So guys, my networks are getting ready now. So if you see, the previous two networks must be already there now. Hub VNet and Spoke 1 both are in the same region, that is East US, and Spoke 2 is getting ready, which is in Southeast Asia. So this is getting created in Southeast Asia at the moment, right? So soon this will be also available. Now what we have to do, we have to create a firewall. So going into all services, I'm going to get into a firewall over here. Now here I'll be selecting the resource group, which one? Hub RG. The firewall name, I'm going to give a name web firewall. Location has to be the same region where your network are available. So currently it is in East US. My hub VNet is in East US. And in order to increase the firewall high availability, you can put it into zones. This is how you can increase the firewall high availability. Otherwise, it's a single point of failure, right? So in the production, guys, keep it in the zones. Currently, we are not in the production workload, so I'll just keep it without availability zone. Now guys, here you will find there are two options available, standard and premium. Now premium will come into the picture, guys, if we are also dealing with third-party firewalls and if we need to implement any sort of the policies, right? Let's say I have created 10 rules, 20 rules or 30 rules in the firewall. If I need to implement the same rule on the another firewall, who will be creating the rule from the scratch? And another firewall can be not only the Azure firewall, it can be third party. So in such kind of the situation, we should go with the premium options so that we can implement the same policies on the other firewall and we can manage with the ease. The standard will also help you dealing with the policies over here, but only with the Azure firewalls only. Yeah. Now guys, currently we will be creating rules from scratch, right? Because we need to understand how we will be creating the rule. So I'm not going via policy. That will come into the picture if you are dealing with multiple firewalls. Currently, I'll go with use firewall because we will be creating all these rules manually. What are those rules we will be creating? application rule, network rule, NAT rule, right? So we will be going via rule option. And here there is an option, create a new network or use existing. So we already created a network for firewall. So I will select use existing over here. So I have selected this particular network, right? Hub VNet. And here I need to create a public IP of the firewall. So I'll give a name, web firewall public IP, that is PIP. And I'm going to click on OK over here. Forced tunneling, if you would like to create an additional subnet for the firewall, I'm not creating any additional subnet. We already created one, Azure Firewall subnet. And guys, none of the option is asking about any subnet. Why? Because we have given the name Azure Firewall subnet. If you will not give that name, you will right away see the error message over here that there is no subnet with the name Azure Firewall subnet. Because firewall is smart enough in order to detect that particular subnet. So if I'll create this, it will take approximately 5 minutes. We will utilize this 5 minutes. Meanwhile, we will be creating other components. So by the time this firewall is getting deployed, I will create one machine over here in work subnet without any public IP, because this will be a production machine. An RDP machine we are creating in order to access this machine. So I will keep a public IP and RDP port enabled so that we can access this to check whether the rules are working, right? So let's say this is my machine. I will target these two machines in order to check whether the firewall rules are working fine or not, right? For the testing purpose. So let's create these 4 machines, and then we will be creating VNet pairing over here, and then we'll create route table. Yeah. Okay, guys. So going back for the VM creation over here. So meanwhile, firewall is under deployment. Let's quickly create our rest of the components. So going into the VM section, first I will deploy work machine. So first I will deploy spoke 1 work machine, and then I will deploy spoke 2 work machine. And guys, while creating this machine, we have to be slightly careful that we are creating these machines in the right subnet. One should not end up creating these machines in the another subnet, guys. So the placement of your resources should be absolutely correct. So here, first I will be targeting spoke 1, going to give a name, spoke 1 work VM. This you will be keeping in your production subnet, right? So here I'll just put this spoke 1 work machine. No public IP of this machine because this machine is under firewall protection. Even though if you will give the public IP, you cannot access this machine, because in the moment you will associate this machine subnet with the firewall, what is the by default rule? Deny all. So I'll just keep it none. Going into the networking option. This is the part that one have to be really careful. Place this machine in the right subnet. Spoke 1 work subnet. None. No public IP to this machine. And we are creating this machine. In the similar fashion, I'll be creating another machine, that is your spoke 2 work machine. And this I will be creating in a spoke 2 resource group. And this will be in the Southeast Asia. So selecting spoke 2 RG, giving the name spoke 2 VM, spoke 2 work machine. No size available. Let me check, guys, what size is there, which is we can use over here. Spoke 2 work machine. Okay, guys. So no public IP on this machine. Placement of the machine has to be correct subnet. With subnet spoke 2 work subnet. This one. No public IP on this. And creating this particular machine. This will take few seconds. Yeah. Now we will deploy our 2 RDP machines. Now we will deploy RDP machines over here in spoke 1 and spoke 2. So going back to the portal, going to the VM, selecting spoke 1 RG. This is your RDP machine that we are creating. So going to give a name spoke 1 RDP VM. And this machine should have the public IP so that we can take the access. And should have the public IP as well. So I'll keep this public IP enabled on this. Going into the networking option, it has to be in the right subnet. So spoke 1 RDP subnet is the correct subnet where we are placing this machine, and public IP is there. So good to go for the creation on this machine. And similarly, creating spoke 2 RDP machine. For the resource group, spoke 2 RC. Spoke 2 RDP VM. Southeast Asia. Yeah, things are fine. Good to go. Okay, guys, so we deployed our 4 machines in the required subnets over here, right? Now, let me go ahead and take the RDP of this machine and let's see before and after effect. What does that mean? Before you will be creating the connectivity and creating the route table, by default, you can open all the websites on this machine. The moment you will associate this particular network with this particular firewall over here, this particular subnet altogether, you won't be able to open any particular website. Okay. So what I will do, I will take the access of my RDP and then I will access this machine and we will see before and after effect for that. So going into the VM section, first we will go to spoke 1 RDP machine. So guys, RDP machine is under creation at the moment. This is about to be completed, guys. This is going under deployment. Any given point of time, this RDP machine is available. Let's see yeah, this is about to be completed, guys. Same goes with the spoke 2 as well. Okay, guys. So spoke 2 has created first, right? So I'm going under spoke 2 first. I'm accessing this machine, guys. And with the help of this, I will access this machine. So I'm under a spoke 2 RDP machine. Connected. Meanwhile, your RDP machine, okay, guys, spoke 1 is taking time. Let it be, guys. Now, with the help of this, I'm accessing spoke 2 work machine and we'll see the default behavior of this particular machine, guys. Just give me 1 minute. This is your spoke 2 work VM. We are in spoke 2 RDP machine. Targeting spoke 2 work machine over here. As you can see, this is your spoke 2 work machine and this is your RDP. Now, if I try to open any website on this machine, by default, it will not stop me to open any website at the moment because this machine is not connected with a firewall. The entire subnet of this machine is not connected through firewall at the moment. So I'm going into local server. Let me turn off this option of IE enhancement security configuration. Otherwise, it will keep on asking me to add this URL as a safe URL. Okay. So this is your work machine where this browser is opened, right? Now, if I'm going to target www.google.com, let's say, what you can see over here, website is able to open, right? Try any other website, www.microsoft.com, you can open, right? It's working. Similarly, if I go to my RDP machine, which RDP machine, guys? This is my spoke 1 RDP. So this time I'm targeting this machine and I will access this machine and we'll see the behavior. Spoke 1 RDP VM, we are in. Now targeting a spoke 1 work machine through that. So going over MSTSC again, going to give a name, spoke 1 work VM. Okay, guys. So inside your Spoke 1 work machine at the moment, yeah, just like we have tested Spoke 2 work machine that we were able to open all the website, this machine should be able to open all the website by default. Now, what we are going to do after that, we will create VNet pairing between the networks where my firewall is available, and then we'll create a route table. Let me turn off IE enhancement security configuration. Let's say www.google.com, and it's able to open, guys. Working fine. Okay. Now what we are going to do, guys, see, we required connectivity between these two networks. So first I will create a VNet pairing between hub and spoke 1, and then we will create a VNet pairing between hub and spoke 2. So for that particular purpose, I'm going into this virtual network, going into hub, connecting hub to spoke 1. So going into pairing, going to click on add over here, going to use hub to spoke 1, and going to put spoke 1 to hub. Selecting the network spoke 1, going to click on add. VNet pairing is getting created. Now similarly, these networks are connected now. Now I will create another VNet pairing between hub and spoke 2. Spoke 2 to hub. Added. Spoke 2. These two networks are also connected. Connectivity is there, guys. Now what else we required? We need to create two route tables. This connectivity is there. Now we need to create these two route tables, right? So in order to do that, going into all services, going into the route table now. And here going to select spoke 1 RG. Location, guys, this is my first route table for the network in the East US. So I'll be creating in the East US. I'm going to give a name spoke 1 RT, spoke 1 route table, creating over here. Meanwhile, this route table is getting created. Let me quickly create another route table, which is for Southeast Asia. That is for your spoke 2 network. So I'm going into the route table over here. And I'm going to create this route table. Selecting the resource group, spoke 2 RG. Location should be Southeast Asia, where my network is available. And here I will put a name, spoke 2 RT. So this is a spoke 1. And now we are creating spoke 2. Now, guys, route table is available now, both the route tables. Now I'm going into your spoke 1 RT. First thing first, guys, after the creation of the route table, what we need to do, we need to associate this route table with this particular subnet. Yeah. So what is the source of the traffic? The source is this particular subnet. This is the source of your traffic, right? What is the destination? The destination is internet. And what is your next hop? Next hop is firewall. Clear? This is your destination. This is your source. Source, next hop, and destination. And first you will be associating this firewall. So you will update the entry accordingly. So going into route table 1, going into the subnet section and doing the association of the subnet with that route table. Going to click on associate. Which network? Spoke 1 VNet. With subnet? Spoke 1 work subnet. Association is done, right? Now where the traffic should hit from coming from this particular subnet. This was the source. So the traffic should go. So going into the routes, going to click on add. Here going to give a name, that is my spoke 1 RT. Address prefix, what is this address prefix, guys? The destination IP address range. What is my destination? Internet. What is that? 0.0.0/0. What is the next hop type? Next hop type is your virtual appliance, which is your firewall. So what we should provide? The private IP of the firewall, because the networks are connected. So how you will point to your firewall? Over the private IP of the firewall. So going inside the firewall and going to copy the private IP of this particular firewall at the moment. This is the private IP of the firewall, copying the private IP and provided next hop. Clear with the picture, guys? This is your next hop, the private IP of the firewall. Provided, going to click on OK. And in the same manner, we need to associate the subnet in Southeast Asia for your spoke to, and then you need to create a route that traffic should hit the firewall, and then the traffic should be going to the internet. So going back to my route table. Which route table, guys? This is your spoke to route table, which is in Southeast Asia. So going into this subnet section, going to associate the subnet. Which subnet? Now this time, this is the source, this subnet, right? Next hop is same, destination is same, right? So what we are going to do now, selecting the source subnet, which one is spoke to work subnet, going into the route, going to click on add route. This is your spoke to RT. What will be the address prefix? Again, guys, 0.0.0.0/0. This is your destination. And here, this is your virtual appliance and the private IP of firewall. Clear? Now, guys, we created the route. Though we have not created any rule in the firewall, but by default rule of a firewall is deny all. So earlier on, I was able to open Microsoft.com. Is it still working, guys? Not anymore. Try to open Google.com, guys. Earlier on, we were able to open all the website. Currently, we are not able to open any website on this machine. Which machine we are talking about over here, guys? We are talking about work machine, which is under firewall protection now. Similarly, the google.com website was working fine. On which machine? On your spoke machine. Try to open, guys. Not anymore. It's not working. Clear, guys? This machine is under firewall protection, guys, and we are not able to open any website anymore, right? How we can allow? Now let's assume I would like to allow google.com. So for that, I'm going into all services, going under firewall, and going to create an application rule. What rule we are creating? Application rule, guys. Yeah, at layer 7. So for that particular purpose, going inside the firewall, going into the rules section, going under which rule? Application rule. Let's say I would like to allow google.com. Now here I will put a name. Let's say app rule, the name of my rule. Now guys, like your NSG that you can create priority between 100 to 4096. Your firewall is capable of giving the priority between 100 to 65,000. You can create multiple rules, guys, over here. As you can see, the capacity of firewall, it is very high. So I'm giving a random priority, guys, because I'm just creating only one rule. So that is fine. And here I will say the rule name is allow Google. What is the source? The traffic is getting generated from the inside of the network, right? These two are the sources, right? So what are the source? Your spoke 1 work subnet and your spoke 2 work subnet are the source. So here provide the source, that is 192.0.1.0/24, 172.0.1.0/24. On which protocol? Let's say if the traffic is coming over HTTP colon 80, HTTPS colon 443, the target fully qualified domain name, which web application? www.google.com. I want to allow this traffic. Clear, guys? We have just allowed google.com over here, and I'm just going to add this particular rule. The moment I'm adding this particular rule, now guys, see the behavior. This is your spoke 2 machine, right? Spoke 2 work machine. Are we able to open google.com? We just need to wait by the time the rule is getting saved over here. We should be able to open google.com on our work machine without any problem, guys. It should work. www.google.com is working again. See, guys. Let me refresh this. Started working? Can we check any other website, guys? Because we have only allowed google.com. Let's say www.microsoft.com. Is it working? No, guys. Only google.com is working. So this is how we can control that only the allowed website people will be able to access from that particular subnet. Because we are not just protecting one machine, it's the entire subnet, right? So any machine that you have in that subnet will only able to open google.com at the moment. Guys, I hope this part is clear to all.
So, guys, I hope you really liked our session. And if you have any kinds of doubts, you can please comment down below and our team will reach out to you. And do not forget to give us a thumbs up. And if you are really intrigued by the kind of terms used and you want to learn more about it, then we have something really, really special for you. We have this free class on Microsoft Azure Solutions Architect certification, that is AZ-305. And if you want to learn more about it, then you just have to log on to K21Academy.com /Azure SA02. In this session, in this free class, you'll be learning about why you should be learning Azure Cloud, your paths to learn Azure Solution Architect Expert certification. You'll be getting to know the difference between AZ-303, AZ-304, AZ-305, and a lot many insightful things. So if you want to do this, then all you have to do is just log on to K21Academy.com /Azure SA02. After that, you'll be seeing this kind of interface. Just click on book your free seat now and select your availability according to the event date mentioned. Add your name, add your phone number, add your email, and every detail will be conversed to you via our mail. And after that, just proceed ahead. On the extreme right, you'll be seeing this kind of link. So just copy this link, save it to your calendars, and I will see you in the next class. Till then, take care and keep hustling.